Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Okay, hey everybody. I hope you all had a great weekend and a great Halloween. Mine was nice. Got to, like I said, on my YouTube post, I've got to do pumpkin carving, which I haven't done in a while. Oh, hi, Adum Toot. Good to see you again. How are you doing this afternoon? But, so today I want to work some more on tessellation. Last stream, I had said that I wanted to try to clean up the files, and I almost am done with that. So I guess we'll finish that up real quick, and then we'll work some more on the height map stuff, which I've also made a little bit of progress on. So before, basically we had done a whole bunch of logic for the all these different tessellation options in the tessellated lit shader, but I wanted to be able to reuse them in basically any shader that wants tessellation. So to do that, I'm trying to bring a lot of this out into its own file. Some of it has been kind of complicated because I've had to do some kind of fancy stuff with macros and defines, but it's turning out all right. Good, but it's night, not afternoon. Okay, well, hope you have a great night then. Okay, so the one thing I needed to do is down here in the domain function. I have all this logic that helps you smooth positions and normals, and I've done that, but I needed to also handle the tangent vector now. The only thing, it's a little different than the other ones because it basically just, I kind of cheat because I don't actually do a Bezier curve for the tangent vector like we do for the normal. It just kind of tries to make sure it stays at a right angle with the smoothed normal. Like this function. So it just takes, so first we calculate the flat bitangent, and then okay, and so then we take the cross product of this bitangent with the smooth normal, and then okay, so okay, I don't need to do some of this probably because the smooth normal will already be interpolated. So yeah, we can just normalize that, and I guess just return this. Let's rename this to the flat bitangent. Okay, so when we have the quadratic normals smoothing turned on, we also need to recalculate the tangent vector so it stays at a right angle with the normal vector. And so what we would do, we need to pass in the flat normal, the smoothed normal, and then the flat tangent. I guess maybe it'd be better if we just calculate them both at the same time. You're not good at programming shaders. What's a tangent vector needed for? Well, that's no problem. I hope these streams might help a little bit. But the tangent vector is used for normal mapping, basically. So you kind of need the direction that, well, the normal vector points outwards from the surface, and it's for lighting mostly. And then the tangent vector points in the same direction as the surface. So it points along, well, you know, when you have a normal map, it's kind of hard to show here, but basically you have it in UV space. So the tangent vector is supposed to point in the same direction that the U coordinate grows on your UV map. So that way normal maps are oriented correctly. on the actual model. I'd like to make a whole video about that kind of stuff at some point. Okay, so the only reason we can technically have a macro that would return 2 values, but it would not, we wouldn't be able to just have this equals, which I think is kind of nice. So I don't know, it's more efficient if we just calculate both at the same time. So I'm kind of trying to decide between efficiency and then I guess clean code. But okay, so I think we'll calculate both here, and then we'll just move this code into here. So we'll have the out. Okay, so now I'm going to need to pass the tangent vectors here as well. Yeah, because I need to calculate the original bitangent. Let's see. I keep going back and forth. So yeah, I don't need to know the I don't need to know the tangent vector when I'm on like if I'm only using the normal vector like during the shadow caster. So technically if we calculate the tangent at the same time, it's a little bit of extra work. But probably. Oh, and also, yeah, we shouldn't assume. Yeah, we don't want to assume that the mesh even has tangent vectors. Now that I think about it. So, yeah, I think we need to somehow have a way to only handle one at a time. Let's do. Okay, so this would be a void. And then we'll have an out. I guess we'll put them at the end. So this will just calculate the tangent and normal at the same time, which I think will, and then we could just choose the one that we want depending on the shader. Okay, so to get, we could just call this function to get the normal. Okay, although, yeah, then we'll have to... This is kind of annoying. Because, yeah, if I call this, and then I'm still going to need to have the flat normal, so I'll have to basically calculate that twice. Okay. What do I want to call it? Because I kind of want to call it this, or call the function calculate Bezier normal, but that name's already used. So maybe I should rename this function, because I guess it does a little bit more. Okay. So this will be, so we calculate Bezier normal. So I guess the thing that's different is we also have this interpolation with the smoothing factor. I don't know. I don't like that name very much, but let's just go with it for now. Okay, so basically I just want to return this so that I can reuse this code. Okay, and so we don't need the smoothing in this one. Okay, so good. So now we can calculate this part. So we need to have the flat normal. It's just like this, actually. There's a little bit of code duplication, but I don't really see a way to get around it cleanly. So I guess we're basically just calling functions, so it's not a huge deal. Okay, so then we have the flat bitangent. Okay, and we'll actually just use this final normal value. And so this is the tangent. Okay, so yeah, we can mark these with an out keyword, yeah, and then that means that this is just a return argument. Line 187, I have recursion. Is that okay? 187. Oh, thank you for catching that. Yeah, it should just be this function. Same with there. Oh, hi, i3. How are you doing today? Thanks for coming by. Okay, so... Okay, yeah, I remember. I need to calculate this flat tangent variable. And for that, I need to basically call this barycentric interpolate with the tangent. variables. And do I need to? No, I don't. I was thinking, do I need to normalize this now? But I don't think so because it gets normalized here. Okay, so I think that covers all of our use cases. So we'll have the smooth normal value, which is just, I guess we'll just call this function. I still don't know about these function names, but they'll be relatively easy to fix, so I'm not worried about it too much. And then we'll have another version that will give us the normal and tangent. Okay, that duplicated in a weird way. And tangent. Okay, so we don't need to pass that there. Okay, I guess out keywords usually go on the end, so we'll do that here. Okay. So yeah, this is a macro. I don't know if I've really worked with them much on stream, or I don't think I've done them in a tutorial yet. But basically when you put in this line into your program, the compiler will replace it with this line. So you can kind of use it to do some fancy shader magic. And any arguments, basically, you can think of it just as doing a string replace. Okay, so I don't. Yeah, I was kind of halfway doing that. Okay, so I need to pass the tangent vectors as well. Okay, and one kind of annoying thing about macros is whenever you want to do a new line, you have to do this backspace character. So yeah, I try to minimize use of them because they look messy, but it's really the only way that I can make this code easy to use between multiple shaders. So I'm kind of stuck with it, but it'll be okay. Okay, and finally we need to pass the out keyword, or the out arguments. Okay, and then I need to also define this in the case where we just have flat shading. In that case, we would just do something like normal world space equals that, and then a back slash, and then we'll do the same thing with the tangent. You didn't know you could write a slash like that? Well, only in macros. Yeah, and then it lets you do a new line. Okay, so hopefully, okay, no error so far. Okay, so let's comment this out for a second. And then we should be able to do smooth, normal, and tangent. And then we can pass okay. All right, so good so far. All right, so let's change it to quadratic normals, which is where, yeah, that code actually executes unrecognized identifier normal world space. Let's see. Okay. Not sure why it's unrecognized because I have it right there. Did I? Oh, I forgot the backslash. There we go. Calculate Bezier normal and tangent. Cannot convert output from float to float 3. Okay. See about that. Probably just use the wrong argument type. Float 3, float 3, float 3. Oh yeah, so this should be a float 3 right there. Is Tessellation supported on mobile? I think so. I'll have to look. Yeah, don't quote me on that, but I think at least the most recent phones should support it. Let's look it up real quick. I'm kind of curious. If I can find. There we go. Okay. Tessellation support on mobile platforms. Tessellation should work on mobile GPUs that have OpenGL ES 3.1 support. So okay, seems that the Oculus Quest doesn't support it, so that's good to know. Okay, well, it's support on the Quest 2, but not the Quest 1. So yeah, it seems like the newest mobile platforms do support tessellation, but not everything. Like even the VFX graph doesn't work properly on mobile. Oh, yeah. I need to... yeah, unfortunately, a lot of the newer technology doesn't work the best on mobile. Hopefully that will change as time goes on. Well, I guess I'm sure it will, but... okay. So barycentric interpolate and implicit truncation of vector type. I probably got a variable mismatch somewhere because there shouldn't be any truncations, and that would probably make things look weird. Let's see. Where's this? One. Okay, so it's just giving this whole macro. Normal tangent, normal tangent. Just scanning everything real quick. Okay, so it's barycentric coordinates, patch factors, smoothing. Okay. Then up here, 3. Float 3, float 3. That's all good. Everything looks good so far. What about here? I don't really see. Everything looks like a float 3 to me. Oh, maybe this is old. Okay, no, it still shows up Sometimes the messages here don't get cleared correctly, but if you click on the shader itself, you can see. Okay, so this actually gives us a bit more information. So the calculate Bezier, normal and tangent, implicit truncation. Oh, still doesn't really give us the correct line number. Yeah, they're able to say on line 170. Thanks for the follow. Let me see here. Okay, let's switch. I'm gonna switch back to this old method and see if it still gives me the truncation error. That way we can maybe... Okay, so no, it is something to do with this macro and only this macro. Okay, what about if I change this? Well, I guess that wouldn't really change what errors the shader gives me. Yeah. Okay. I'm sure it's something silly. I don't really want to move on because then I'll kind of forget probably. Let's see. So we have, I mean, everything's a float through here except for the smoothing. Am I like passing the wrong order of our arguments? Oh, is that? Oh no, this is the wrong thing. So yeah, barycentric, smoothing, the Bezier points. Okay. Hmm. All right. Well, I don't really see any bugs. I feel like if it was dropping some coordinates, then we'd be able to tell for sure because the lighting would be all messed up. Let's maybe just output the tangent vectors here. And we can kind of see if it looks strange. Okay, well they're definitely 3D, so that's good. So I don't really think the tangent vector is getting truncated. And we kind of know that the normal's not because we can, it looks shaded. So maybe, I don't know what that error is talking about. So I don't see any place that's getting truncated, but maybe, wait, is this tessellation smoothing? It's just a float, right? Yeah, okay. I was just making sure because if it was like a float too, then that would explain things. And then barycentric interpolate should return a float 3. And then we normalize it, so that's not the issue. See, what if I just like define this as nothing? Okay, well, that's gonna say is used without having been initialized. So what I need to do is set normal equals tangent, world space equals 0. Yeah, and this is gonna look bad, but I just kind of want to see if that makes the... No. There's still truncation, which is weird. I guess it could be happening here. Okay, so that makes it go away. Then that means it's in this section? Oh, I know what it is now. Okay. Yeah, okay. Yeah, the tangent vector, it's easy to forget, obviously. Well, apparently, because the tangent vector is actually a float 4, because the fourth component, again, is the like a sign to apply to the final bitangent. Yeah, so we actually just want to do this. I think that will get rid of the error. So I guess I should do that up here as well. Okay. Alright, so that was kind of a silly tangent, but it's alright. Okay, so now we can get rid of all of this code because we've moved it. So is there anything else that I can simplify? Most of the stuff has to do with the actual shader and not really the tessellation, so I think we might be done. Okay, so I'm pretty happy because, yeah, before all of this code was inside this shader, and it wasn't able to be used by any other shader, but now theoretically we can just include this file and then have all the same tessellation options for any shader that we want. Okay. There is one other, I wish, because like we have these lines for all the tessellation options, and I wish that we could move these out and put them in some common file, but I don't think I can do that, unfortunately, because I don't think I can define my own pragmas. Because Unity has these specific ones for this very reason, so you don't have to define these lines multiple times, but I guess, let me see. Unity, create, custom pragmas. Use pragma directives inside if directives if the expression depends only on define. Yeah, so so I can do an include with pragmas directive. Okay, so I guess theoretically I could have like an include file that only includes these lines, and then we have you include with pragmas that file. I don't really know if that would be, I mean, maybe it's a good idea. Okay. Okay, that's kind of... I'm just reading this. Maybe because like in any shader that we have tessellation, we're gonna have to copy and paste this this long line here for every pass. So it'd be nice if I could. I mean, I'd really like if I could just do my own specific Pragma thing, but it looks like you can't define that. So let's try. So this is gonna have to be its own file, but I guess that's okay. Okay, so let's see if this works. So it was include with Pragmas. Tessellation Pragmas.hlsl. So let's see if that works. If Unity can do this, then you can do this. Yeah, I don't think Unity allows you to do custom things like this, because if I'd love to be able to just do like Pragma multi-compile, I don't know, NMG tessellation, but I don't think I can do that. Maybe though, I've never do some more research. Okay, but at least I can use this include, so I guess this is kind of a way of doing it. Okay, so I guess I should make sure. So if I change this, okay, it does update, so okay, so that's good. So now I can replace all these lines here, and now if I ever need to change these keywords, I can just do it in that file, and I don't have to do it for every pass, which is a big plus. I did want to add for this wireframe, we also have this for different partitioning options. Okay, this can also be local. Okay, and then we can add this. So I guess the only other thing, it'd be nice if I can also include all these keywords in a file, so that way we could just support them. So let's see if we can add one more. I'm getting pretty fancy here, but maybe we can do Tessellation Properties. Don't know if this will work. And then I can copy this. Okay, and then hopefully all these properties will also show up. Okay, now that was too much to wish for. Okay, apparently you can't do that with properties, so that's a bit of a shame. So any shader that wants to use this will have to still have to define these properties every file, but I guess it's better than nothing. where there are gaps on the model. Basically, this model is just, it's not really made for tessellation to work. I just pulled it out from Blender to test how it looked, but you can see when I turn off the tessellation smoothing, it's fine. But then when you turn on any kind of smoothing, just because of the way it's built, it doesn't look right. So if you wanted to fix this, there are a couple ways you could do it. First, there's something I wanted to look into, but like you can use Vertex Colors to kind of define a smoothing amount. So you could set the smoothing at these points to 0, and then they wouldn't smooth. Excuse me. And then they wouldn't smooth, so they would stay straight as they were. Another way you could do it is basically in Blender add another edge loop here, and that you can use that edge loop kind of to control the amount of bending. So we might look into that, but I don't know. I'm not the best at 3D modeling, so. Okay. All right, so that's pretty good. I guess I should check here if I can do different. Partitioning. Okay, so I know it's on integer. And then if I change it to fractional even. Okay, well, it's kind of hard to tell because it's not smooth. So if I do this. Okay, yeah, you can see the tessellation is increasing smoothly as it gets closer to the camera. I guess an easier way to do it actually would be if I just turn on the tessellation mode to constant. Oh, does this not work? Okay, no it does. So if we change that and then change this to integer. There we go. You didn't know that models had to be created for tessellation. I don't think I understand the sentence. Oh. Well, yeah, it's just, this technique for tessellation is not, it doesn't work for all models. Specifically, ones that kind of have these crisp edges, it doesn't look the best. Well, I mean, yeah, you can still do tessellation on it. You just can't have the smoothing. So you could turn smoothing off and it would be fine. Okay, so that works. And then check odd. And then this power of 2 seems to work just like an integer. Or it seems to work just like integer mode, so maybe it's different on other platforms, I don't know. Oh, that went quick. Okay. All right, so I think that's all working. Okay, so let's go back to the or the height map. And first of all, I want to add all of these options to the height map shader. And then I want to merge this branch into the master branch and then see if we can fix up some of the problems with the wireframe shader. Guess I'll turn all these back on before we exit the scene. So the height map, we were having trouble before. Basically, the normal was too extreme for the height, and it's still kind of like that. I've done a lot of research, and it's really a difficult problem, mostly because it's hard to find out the size of one pixel in world space because it's dynamic. Or not one pixel, one texel, yeah, which is basically a pixel on the texture. Yeah, because it depends on like the texel density in the actual UV map. So I think technically you can calculate it, but you'd have to make a pretty complicated tool to like bake it into the model's data. So I don't know if that's a little bit like outside the scope of this tutorial. So we'll probably do something simpler, but I do have a couple ideas. But first off, I want to update this height map to use my new Tessellation common files. So, okay, there's no reason to have this properties file anymore, so I'll just delete it. Probably just to make things easy, why don't I don't know if it really matters, but I'll just copy these properties and we'll put them in a comment at the top of the common file so that way we can have them readily available. And then in the height map, okay, so yeah, we just have the partitioning algorithm, but go ahead and add all of them. And okay, and then we can add our special include with Pragmas line to every pass here. Every pass except the meta pass, that is. Okay, and then in the HLSL file, first I need to add tessellation smoothing and the Frustum tolerance to the buffer here. Okay, and then I need to include the tessellation common. Okay, so this is the same. The control point is the same. Okay, yeah, I have, let's move this tessellation factor structure up by the other ones. And so what I can do, let's clean this up a little bit. So in this common file, I have this macro. So I could just do that. Okay, and this file actually doesn't need the Bezier stuff. So I can, let's see, I can turn, oh, what am I trying to do? Yeah, so yeah, this one doesn't need smoothing because we're gonna handle that ourselves. So yeah, we can get rid of that part. Mostly I wanted this tessellation factor. Is MetaPass for light map making? Yeah, that's right. It's basically the light mapper uses it to find like emission so that you can bake that into light maps. Okay, so yeah, this is fine. Okay, so here you can grab some of the code from here. So this uses a macro. First we set up the instance ID for instancing. And then we see if we need to clip a patch. And if so, we tell the tessellator to clip it. And then if it's not clipped, then we calculate the factors. But yeah, we don't need to do the Bezier points this time. I think if tessellation works in the meta, that would be max possible settings level. That's true. The tessellated shaders I've looked at before, they usually don't have it on the meta path, but I should probably look into that before I publish a tutorial. Oh, hey Gawi, it's been a while. How are you doing? Yeah, you're right. It has been a while. Yeah, I've been pretty good actually. How are you? I'm sorry. I feel like I keep having to change my stream time, which is kind of annoying, but I don't know. It's been such a pain trying to find a consistent time to stream. So I hope this time I'll be able to be a bit more consistent at. Okay, so this partitioning mode. Yeah, I don't need to include this part anymore because I've condensed it down to this macro. Okay, so we can still do this because we're not doing any smoothing, so I think that's it. Nothing else from the common file. Position, clip space. Okay, so we need a clip space position in this tessellation control point. Which is fine, I guess. Technically, yeah, we're not really going to use it because we recalculate positions later on, but we need it for Frustum Culling, so it's fine. So this would be SV position. Okay, and then I can add it. So we already calculated it as part of this position input, so I can just add a line here. Okay. So you can see it's culling a bit more than it should, so I'm going to turn up the tolerance. Usually 1 is pretty good. Okay, and now I should be able to change the factor. And we'll change this to fractional odd. Okay, it's hard to tell here, but like as the tessellation goes more detailed, the height map also gets more detailed. But I guess it's kind of hard to tell because the normal is sort of smoothing it out. Let's see, so if I change this height to be pretty big, you should be able to tell. But yeah, now at this point, the normal doesn't really make sense. Oh. Okay, but anyway, so as we increase the tessellation factor, you can kind of see the geometry smoothing out, which is, yeah, the effect of it. Because, yeah, every time you tessellate, you're able to add more vertices, which add detail to the actual geometry. So let's see, we can change this to integer, and then it will kind of jump as we group. Maybe turn off the wireframe, I don't know. But yeah, so here you can kind of see a little better. Yeah, the shadow kind of, it would be really smooth if it wasn't for the shadows, because the shadows have the low poly look of the actual terrain. The shadows still aren't the best. Like there's some weird artifacts right there. Seems like the Frustum Culling is also not the best right there either. Oh, you know what? The Frustum Culling. Oh yeah. Okay, so the Frustum Culling for this, yeah, it's actually, since we're changing the position a lot, we're gonna have to change the way that we do Frustum Culling. That's a good point. I hadn't thought about that, because right now we're culling based on the original position. So that's why when I had this one, it's getting culled because its original position down low is not in the camera, but it's not taking into effect the new position of the mesh. So we need to, I guess we just can't really cull here unless we take in like the maximum height, I guess it could be. How can shadows be fixed? Yeah, we're gonna have to play with it a little bit. I think the problem, I think it still has to do with the normal vector being kind of strange. So maybe when I fix the normal vector, the shadows will also look better. Because it probably, having the normal vector not actually being normal to the terrain will make this shadow acne a little bit more obvious. But yeah, we'll definitely play with that. Let me see here. Okay, I can undefine this. Alright, so let's fix Frustum Culling real quick. So basically, I need to be able to have like a Frustum dimensions here or something. Let's see. Maybe instead of using instead of trying to include all of the stuff in the comment file, I should just write my own function because it's kind of specialized. Well, it's technically not dependent on the normal, but when you apply the shadow bias settings, the shadows are offset by the normal, like here, this normal bias. But the normals doesn't actually work right now because it's not the real normal to the terrain, if that makes sense. So that doesn't work perfectly. Although you can see even when, this might just be, this part might not even be shadows now that I think about it. Let's turn off. Yeah, so this weirdness stays even with shadow casting turn off. So that's just artifacts from the normal vector. Oh yeah, so this should be fixed when we deal with that. It looks, you can kind of see, I think it's probably from the pixels on the texture. Let me see, oh, I already turned off compression, so that's not it. Anyway, we'll come back to that. Okay, so Frustum Cull. I could just add like a minimum and maximum size here, or dimensions. I guess it just needs to be a float 4 because the dimensions, our clip space is in 2D. Well, I don't know. We could also change the depth. Why am I using a texture instead of generating noise? Well, it's just more, I guess, easy to switch out because you could just create different texture maps or height maps and then switch them out instead of, otherwise you'd have to go develop your own algorithm for whatever kind of terrain you want. But yeah, if we were making an algorithm, this would sort of be simpler, I guess, as long as it's smooth and what's it called? You can find the derivative of it. Then you could find a perfect normal. So I did something like this in my grass video. I'm trying to think about, or my grass system. Maybe I could just pull that up. I don't remember. Let's see. This needs to be, I need to clean up all these files as well. But I have soil. Oh, right. It's in this folder. Oh, okay, so I already had this. So yeah, I have this dimensions, which is the dimensions on the screen. I know that though. See, I think Catlight Coding has something about this. Let me pull that up. Catlight Coding is a great website for a whole lot of different shader things, so I would definitely recommend it. But they have, let's see. Thought I looked in or saw something about this. Oh, they also have something about shadows, so we might look into that. But oh, that's interesting. Oh, I see. I'll have to look into that, but I'm not sure if that will really matter. Okay, so this is what I want. Frustum Culling. Yeah. Okay, so they're actually handling it a little differently. They're culling in world space instead of clipped space. Yeah, so it's a different strategy. I guess that's one advantage of doing it his way, is that we do know the actual like world space maximum displacement. Okay, so how did I do it on my grass shader? Okay, so I had the culling. Okay, gotta make this more confusing. Yeah, it's using a different camera, but okay. So the clip dimensions, all I did was transform the maximum dimensions in world space into clip space. So I guess that will work. Okay. So let's add, I guess we'll just take this function. Okay, yeah, it looks like I already copied it mostly, but I took out the dimensions. Okay, I see. I guess the problem here is that we don't know, should the dimensions be centered? We kind of want a different tolerance for each dimension, which is kind of what I was thinking of. So maybe this is getting a little bit too complicated, and all we really have to do is just increase the tolerance until we don't have any issues. Okay, I think that's probably the best way to do it. I guess technically you could maybe be a bit smarter, but I don't know. Kind of want a general purpose thing here. And plus, yeah, this is also, the height map is way higher than it would probably be in any actual system. Let's see. Although I'm gonna have to... Is it not gonna... That's weird. So maybe the variable's named wrong. Okay, so let's just never clip. Okay, so that works. Then how come when I like increase the tolerance to super high values, it doesn't change anything? Oh, I'm using the wrong material. Okay. There we go. So you just need to find a value that works for your mesh. Okay. So now let's try to fix the normal. So what I'm going to do here, this will be kind of like a terrain shader. So like I said before, the problem with normals is it's hard to move from UVs to world space because you can't really get the UVs, like the scale of one like unit in UV space and world space, because it's dependent on the triangle on the mesh, and so it'd have to be like built into the actual mesh data, which is not, we don't have by default. So I'm going to kind of go the other way around and define UVs based on the world space position. So that way we will know the size of one, I guess, unit in UV space and world space. So since that's the case, we don't need the real UVs anymore. Why do I have the tangent vector? Because I'm not doing normal mapping. What do I need this for? Get normal from height map. Okay, I don't know what that is. Sorry if you can hear it. Oh, because we're calculating. Oh, right, because we find the normal in tangent space and then we move to world space using this tangent to world calculation. So does that actually work? Like if I change this to a sphere? Oh, okay, that does. It kind of looks cool, actually. But oh, what's this? It's like a hole in the top. I think that's because of disjoint UVs. Yeah, so this is another problem. The UVs aren't smooth at that point, so there's like a hole in the terrain. Oops. But anyway, so I guess if we're going to be creating the UVs based on world space, we kind of also have to define our own normal and tangents. So yeah, I guess we won't use either of these. Is that true? Yeah, I think so. Because yeah, this is just gonna be a terrain shader. In fact, I think I might just rename it. That looks thick. Yeah, for sure. I would like. Oh, well, before I do this, I should create a branch actually. So yeah, let's take the work I've done so far, and we'll merge it into the master branch, and then we'll create another branch to try this new shenanigans with the height map. Okay, so extract, tessellation, logic, and update both shaders. Okay, so just make sure I'm not including something I don't mean to. I don't know if you can hear that, but let me just figure out why somebody's hammering right now. Okay, so we want to switch to the master branch and merge. Okay. Yeah, and I guess we can remove this branch because we don't really need it anymore. Okay. Let's make sure nothing happened. All right, looks good. All right, and so now, okay, apparently me just switching that scenes like that made me have to recommit, but that's fine. Okay, so now we want to create a new branch, and we'll call this, I don't know, world space terrain. How about just terrain? That'll be fine. All right. Okay, so now, yeah, I can work without having to worry about deleting all everything I've done so far. Okay, so let's get rid of all this stuff. Light maps. So I guess we can't really do light maps because this terrain. Well, no. Okay, so what we'd have to do is make. Oh yeah, so we just need to make a tessellated meta shader, I guess, because we need the light map UV. Okay, I'm gonna have to. I don't know about how light maps will work with this. We'll have to test it out because we're not really using the actual UVs anymore. But is Unity smart enough to keep the UVs for this terrain? I don't know. Words are just kind of coming out of my mouth. I don't know if they're making any sense, but okay. So since we're not using the UVs for the texture because we're going to define it on world space, I wonder if the light mapper is smart enough to assign the correct light map UVs based on that as well. I don't know. We'll have to test it. Regardless, we don't need all this stuff. So I guess we'll just pass. It'd be kind of a shame. Yeah, it won't really work if the terrain can't have light maps. But okay, so we'll leave this for now. Let's just go for how far. Let's do what I've gotten so far. Okay, so on the vertex stage, we need world space and clip space. So I guess technically we could convert world space to UVs at this point, but I don't really know if it would be... I guess we'd save a little bit of work, but we'd also pass more data. I don't know what would be better. I think it's probably better not to calculate UVs right now. Okay, so anyway, we'll just do that. We don't need the normals anymore. Okay, yeah, we'll leave the light maps on for now. Okay, so in the patch constant function, okay, so yeah, we'll still have all this. I don't think these need normal, so it should be fine so far. Okay, the domain or the whole function is fine. This stuff, I guess we'll keep, although it's probably going to change. So, okay, so yeah, we have the position, and then the normal is just going to face upward. So we don't really need to have it there. Okay, so the UV, this is where the magic's going to happen. We're going to convert the world space into UVs here. So we have a scaling based on, I guess we'll get rid of some of this stuff. The main texture, scale, and transform right here. We don't need that anymore. Okay, so we'll use basically the transform text macro on the position world space. Okay, and that will apply offset and scaling to it. And yeah, I think all this can just go how it is. Okay, the thing is now we do know the scale of 1 unit in UV space. But what is it? So I guess it's okay. So I'm trying to remember the transform text. I always forget, is it's the scale and the X and Y coordinates or the Z and W? I think it's an X and Y. So we don't need the normal on tangent. So we'll need the UV and then also the world space pixel size. Okay. X. Okay, so actually, yeah, we shouldn't. Okay, yeah, I'm thinking about this the wrong way. Probably let's just call the sample offset And to make things simple, I'll just make it a square. It doesn't really need to be different for the X and Y positions. So yeah, we'll just sample offset based on this, and this will also okay. What? I'm confusing myself trying to update this shader. Probably the simplest way is I should just have a function here, float to world space to UV. Okay, and so we'll take a position and world space, and that's it. And then turn that. Okay, and so instead of working with UVs, we'll work in world space, and then we'll just call this function to deal with it. Why don't I store normals in the texture? It's more performant that way. Well, just because I'm trying to render a height map. So if you want to have a variable height to your height map, your normals won't be correct. So yeah, so what we'll do is position. Okay, and then yeah, instead of passing the UV directly, we'll just do this. And unfortunately, we have to have multiple versions of this to make it work with different functions here. And then, okay, so we know the size. Well, it's basically, I guess we don't actually, so. Okay, yes, that's right. And then we could do the same thing here. Multiply the normals on the height amount. Well, because like, imagine your, the height map will be easier to show when the, oh, what's it complaining about actually? Main text. Oh, it's probably called main texture. But like imagine you have a normal on the side of like a mountain, and you have a variable that changes the height of that mountain, then the normal doesn't really scale with the mountain. It, because like the higher the height is, the more closer to parallel that normal would be. So and it's difficult to calculate that if you only know like the actual point that you're on. So what we do is we sample, so you kind of have to sample neighbors like we're doing here, and so there's not really any point to have a separate normal map. Oh, okay. I'm glad I'm explaining it. Oh, all right. All right, so what was I doing? Oh, here, yeah. Okay, and this should all be float threes. Okay. So we don't need a normal or a tangent vector. Okay, so now we don't have the UV there because we'll just pass in the position. Okay, same with this. Except I need to have a sample offset. So I guess that will be an option here. All right, so let's do normal sample radius, we'll call it. Where was it? Oops. Okay. So I guess I don't really have to pass these at all. We just need to pass the position world space. Okay, so that means that then we need this in here. Okay, so before I fix those, the data interpolators, let's go ahead and make sure everything works here. So we need position, world space. Okay, so technically you could simplify this by calculating the UV once and then passing it through here. But I guess we can't really do that because, yeah, we have to, yeah, so this is fine. Because we're not actually sampling at the specific UV, we're just using this as like the center. Oops. So normal sample radius. Okay, so yeah, we can get the actual UV, the world space to UV. Is that the right function? Yeah. Okay, so let's change the, well, I guess this is still kind of correct. I was going to say requires position fragment calculator, but that's not right because we're actually calculating the world space. I guess we could change this to be requires position interpolator, but I don't know if that makes it any easier to understand. All right, so basically in this interpolator, we just need the position world space, and then in the forward lit pass, again, we'll have UVs or the light map, and then vertex lighting. Okay. So let's see how it looks. Normal world space. Oh, right. So we don't, basically this tangent space is in world space now. Well, I guess technically not because Z is up. So to transform this to world space, all I have to do is return normal tangent space X, Z, Y. Because in tangent space, Z is the up and down, where in world space, Y is up and down. So it kind of could just flip them, I think. But we'll see. Sample height cannot convert something to something. What did it say? Oh, right. So, yeah, we're actually supposed to sample a position world space here. Or use a position world space, not the UV. And again, it's annoying that I have to write two versions of this. Maybe I can do, actually I could probably do this with a macro. So maybe I'll try to do that. Or clean this up with a macro, I mean. Okay, so yeah, neither one will offset in the Y position or Y direction. Okay. Oh yeah, I need to pass the sample offset. Normal world space. Oh, right. Okay, so we don't know the normal here, but it's actually just up. So I can just do float 3, 0. And I know it'd be better if you just put height. Well, I guess we could do it, but. Sample. Okay, so the spherical harmonics needs a normal vector. And this is always just going to... Oh, wait. So actually, so for this, we want the actual normal vector, which we have to get for the shadow caster. Okay, so now I guess we should just sample spherical harmonics per vertex or per fragment. That doesn't sound like a good idea. Because the problem is we don't know the normal vector here. Okay, but if this is a terrain, then it'll always have a light map anyway, so I don't really need spherical harmonics unless we're gonna give up on light mapping. So I think I'll just comment this out and we'll see what to do about that. Okay, and we have the same issue here. What should we do? I mean, we can figure out the normal here, but then we're gonna have to I guess it's okay. Well, this might be a good way to show, actually. Maybe I'll have an option to do per fragment height our normal map. Because this is a good way to show that if you have an expensive operation, you can do it in the tessellation or the domain function and then just interpolate it in the fragment function. Okay. So it seems like we're going to always need the normal now, the real normal. Well, I guess. Okay, so technically you only need it in the lighting pass and the shadowcaster pass at this point. Let's see here. Okay, so let's make an option to have interpolated normal. Okay, so this is going to be kind of complicated actually, a little bit, because if we have an interpolated normal, then we don't need the position here and then in the depth normal pass. Okay, so let's see. So we need a world space position in the fragment function. Okay. Actually, maybe I should just make sure it works before trying to optimize. That's probably a better idea. Okay, so let's just always include this for now. I don't know if this will really work either, but okay, so we have world space position, and then a normal vector. And the forward let pass will have this stuff. Oh, I actually was doubling up on the text chords there, but so again, and if we're in the shadowcaster or the forward let pass, we need a normal vector right now, but I'm just gonna go ahead and calculate it always for the moment. So this is, I guess this is just a normal. So this keyword doesn't exist anymore. And then we'll always just output the normal vector. Okay, so now we have the normal vector, so we can do the spherical harmonics and vertex lighting. Yeah, we don't really. I guess it's fine. If I'm going to do that though, it should be symmetric. Okay, so. Okay, so I'll comment this out. So yeah, we'll have, right now I have the float normal vector from the vertex stage. Okay, so this should work. No. Oh, right. Oh. So let's make the height something pretty small to make it a little bit more manageable. Okay, so first off, you can see it's all black. So that means that I think the normal vector is not being generated correctly. But that might be because, yeah, I think I forgot to add an option for the normal vector radius here. Oops, that's the wrong shader file. Okay, so I already have this horizontal multiplier, which is from an old thing I was testing out. So this is the normal sample radius. Okay, so that might help. Okay, good. So it's not black anymore, although I think the normal is not right. It's hard to tell because it's repeating so quickly. So to fix that, I can set the tiling to be smaller. Okay. Well, actually kind of looks cool, but that's not what I want for now. Although I think this is per vertex normals in action. Let's see here. Let's make sure that the normal actually is correct by just outputting it here instead of the color. Okay, so it should be mostly green because that means it's pointing upwards. But hard to tell what's going on, but I think it might be reversed because it should be bluish. I guess that's right. It should be bluish when the slopes are normal to the Z, or pointing towards the Z direction. But I probably should just make this higher and we can tell easier. Okay, so yeah, it was right. So yeah, they're bluer pointing this direction, and they're also more red pointing towards the X direction. Okay, but you can kind of see these star shapes, and I think that's the tessellation. So let's see if we increase this. Oh wow, that's not the effect I was expecting. So I think something is incorrect, obviously, because as the tessellation increases, the swimming effect should be less apparent, I would think. Maybe maybe this sample radius is too small. Okay, yeah, so it smooths out a lot if you increase this. Okay, so I think that was actually the problem. because I think it was too sensitive. And since we're using a texture, you have to be careful that the size isn't smaller than the actual like pixels on the texture. So that would be a good reason to use like a noise function instead, but I don't know if we'll deal with that in this. Okay, so you can still see the effect a little bit. So I think you have to just play around. I mean, it actually kind of looks pretty in its own way, but it's not really what I want right now. So I think you just have to find the right value. Okay, so now let's turn back on the lighting. Okay, and this is with still a little bit going on. Okay, so if I set it to 1, I think that's too much. Okay, I think that's pretty good. Now, if I decrease the tessellation amount, yeah, it starts to, I guess, I don't know, low polyize, I don't know the term. And that's because the normal is calculated per vertex. So we could improve it by calculating it per fragment like we used to do. But it makes it a little bit inefficient because we already have to calculate the normal up here in the domain function for a lot of the passes. But okay, so let's see here. We'll add another option. This will just be calculate normal and fragment. Is that right? I forget how the toggle works. Do I have to? I think I have to include it twice here, so. Okay, and so now I need to include a Pragma shader feature local for that keyword. Excuse me, I wasn't sure if I was going to sneeze there or not. Oh gosh, looks like I fogged up my glasses too. Anyway, okay, so where was I? Okay, so we need this in the forward lit pass. And then I guess also the depth normals pass. So maybe this isn't going to be as complicated as I thought because we don't even have to include this in the depth only or shadowcaster pass. Okay, so that's nice. So we only have to pass the normal into the interpolator. Oh, this is the wrong file. Okay. So let's see here. I guess we always have to pass the world space if we have to sample a texture. And you know what, actually, so in Unity, they have a optimization where the depth normals pass never has per fragment normal generation. So I think I'll do that here too because I don't think it's super needed. Okay, so oops, the wrong shader again. So we need the world space for the lit pass only. And we need the normal for the depth only pass or the lit pass if it doesn't have per fragment normals. Okay. Let's see here. How do I want to do this? So if not defined forward lit pass. Let's not do this that way. So if not defined, I guess it would be defined depth normals pass or oops, defined forward lit pass and not per fragment normals. Then we'll define requires normal interpolator. Okay. Yeah, and this kind of stuff I think is worth it to try to get correctly because having unneeded interpolators can actually slow your shader down a lot. So even though it's kind of annoying, I think it's worth it. Okay. And then the position is now only needed in the lit pass. Zero, 1, 2, 3. Technically, like if it's the 4 lit pass and then calculate normal and fragment, oops, is defined, then this we'd have nothing in text chord 0. I'm not sure if that's going to cause an issue, but it's going to be kind of annoying to fix, so I think I'll just leave it for now. Okay, so if def requires normal interpolator. Okay, so this should get stripped out of any shader that doesn't use it. So like the depth only pass doesn't actually use this normal value, so I think it will strip out this line and not sample it or not calculate this. So we should be good. Okay, so that's fine. And then we can do if I guess it'd be like this. If calculate normal and fragment. Let's do that. Okay. Oh, yeah, I forgot to put the type. Valid conditional expression somewhere. Okay, did I forget to... Gonna go to sleep. All right, Adam Toot, thanks for coming by. Yeah, I should be live tomorrow at about the same time, I'm hoping. So have a good night, and I'll see you later. Okay. What am I doing? Or what's it complaining about? Valid subscript normal. Oh, right, because this doesn't exist if we calculate the normal and the fragment. So let's just do that, and then else split 3 normal world space equals this. Valid conditional expression at 34. Okay, well there's not an, oh right, I think it's complaining actually here. So this should be if def. Okay, so now if I turn on, okay, so that's sample, no matching one parameter function. All right, so now the normal might not be in the output, so yeah, we should just do that. I think in case something similar happens. Okay, so yeah, you can see that when we uncheck this, oops, Unity will work. Yeah, it makes a pretty big difference on the smoothness of the terrain. We can even, so now we have a pretty small tessellation factor. And probably, it'd be interesting to know. I think calculating the normal per fragment actually does have quite a big performance impact because we have to calculate, or we have to sample the height map 4 times, but it does look pretty good. But yeah, you can, if you turn it off and then you turn up the tessellation factor, the higher the tessellation factor, the the less that you need it. So if you have a high tessellation factor, you can have it turned off. So let's fractional odd, and if we turn this to world with depth mode, so that we have a more variable tessellation. What's going on there? Yeah, okay, that's pretty good. Yeah, this, you have to play around with that factor quite a bit. But here you can see, let's turn this off. And okay, yeah, so we have the, so far away, we have normal per fragment, and then we zoom in. You can't really tell what's going on, but it's actually, the height map is getting more detailed as you zoom in. But if you turn this off, it's more obvious, but it's still actually not too bad. It looks kind of bad right here. So would we maybe increase? Well, if you increase that, you can make it a little smoother, but the normal starts to not, be as defined. Like right, this edge looks kind of funny. So it's kind of a trade-off. I think this is why usually you don't really see a lot of real-time height map rendering. Usually people do it like with Unity Terrain. They take the height map and then bake it into a mesh at build time so that they can do complicated algorithms to kind of like figure out a bunch of this information at once. But it's still kind of a fun experiment, and it shows, I don't know, if you had to do this at real time, you have the tools to do so. Let's see. Okay, so let's look. What else do I have to do? Oh yeah, so we can maybe do this Vertex Colors thing for the dynamic tessellation factors. I don't think I'll do this. Yeah, we should. Oh yeah, I should check lighting for the the terrain, actually. Okay, so I think this I was going to find like a complicated lighting algorithm to show how you can optimize it by calculating lighting in the domain function, but we kind of already did that right here, where we have this normal and fragment, or per vertex and per fragment normal. So I don't really see the need to do another one. Okay, and then here you can actually recalculate normals in a whole shader for vertex animation. Maybe we'll do this, but I think all I'm going to do is just kind of pull over the... So what, I don't know if anybody's looked at my foliage shader. You deform vertices based on wind, but it's actually, we kind of have a similar problem where it's difficult to create the normal vector from that. But since in the domain function you actually have, or I guess rather in the whole function, you have all the information for a complete triangle, so you can actually find perfect normals that way. Although they are going to be flat shaded because you don't know anything about the surrounding triangles really. But for like grass cards, that's actually ideal because you don't really care about surrounding triangles because you're just like a flat piece of paper. So I kind of wanted to showcase that, but it's going to be relatively simple, so I don't know if we'll do it on stream today. Okay, so what else do we have? Okay, so this was something I thought looked pretty cool, where you can kind of dynamically tessellate based on where you need it. So say you had, I don't know, like a tin can or something, I guess a Coke soda can, and then you wanted to be able to deform it. You could tessellate areas where you're applying a height map more than the rest of the mesh. So that's one thing you could do, but it's kind of, we can see, because it's kind of like a combination of using these vertex colors. And then this domain output topologies. I don't know if we'll do that because that kind of, you pretty much always use triangles in Unity, so that's a bit more advanced. So I don't know if we'll do that in this tutorial. Let's see. So what else have we done? We need this. Okay, so we kind of did that by sidestepping the issue. So I guess that's a question. Do I want to try to make a version that doesn't... Let's see. I guess I should write a note. Okay, so height map on arbitrary object or arbitrary mesh. Bake pixel size. So I guess it'd be world space pixel size into mesh data. That's basically what you'd have to do to be able to create normals correctly. So I think, like I said earlier, that's kind of complicated, so I don't know if we'll do it. But I think I do want to do this vertex colors because it kind of fixes an issue with the little monkey. Yeah. As I was talking about earlier. So when you tessellate the monkey... Oops, come on. I feel like there's a way. Sometimes I want to be able to zoom in more with a fine tune, or like with finer controls. So there's probably a way to do it, but I always forget. Anyway, let's see. So here, if we turn, okay, so we have linear normals. Let's just turn on constant. Okay, so you can see when we tessellate and try to put the smoothing on it, causes holes to form in the mesh. And I think that's because, I wish I could zoom in better. But I think that's because the normal vector for these points are diverging, so it causes the Bezier curves not to meet each other. That's because it has like a crisp line. I'm surprised it doesn't happen to the sphere actually. But I guess here, even though these normals don't diverge, the normals all point in the same way, so there's no smoothing to be done. So let's create a really simple mesh that we can try to test this on. So I'm trying to think. I don't want to spend forever making a mesh, but I kind of like something that has a sharp and a smooth edge. And we can see how we can try to get them to work correctly together. Like I said, I'm not the best modeler, so, but I think I'm gonna do maybe like an axe head or something. Okay, so basically, what? Oops, what happened there? Something like that. Oop. Try to make it roughly equal. I mean, I guess it should be a complete point, so maybe I could just merge. Well, I don't really want to merge the entire thing, so I want to merge these two and these two. Okay, so I think this is actually good because one way we can leave, or we can put an edge loop on one, and then the other one we can leave how it is. So let's add a little bit more to it. Oh, okay, so now I've kind of messed up the geometry of this a little bit because they're not, because I've got a triangle up here, so it's not gonna want to do edge loops. Okay, so maybe we'll do something a little bit different. What is going on? Okay. There we go. I didn't really want snapping on. They don't really have to be perfect, but anyway. Okay, so now we've got like a kind of simple axe head type thing. What is going on? Okay, so now if I give it the material, okay, so nothing happens, but I think it's because the normals aren't smoothed. So, let's see. Yeah, because if we turn up the tessellation factor, we don't notice anything, even though I do have Bezier on, but it is getting tessellated. So what I should do, okay, let's see here. Oh, I don't want to recalculate inside. I think they're still going to be flat. I think I have to go into Unity. Well, I'm sure there's some way to do it in Blender, but I can also just do it here and say calculate. Okay, so now we can see the Bezier algorithm doesn't really work well for this because we want it to have sharp edges. I'm a little surprised that they're not sharp even where we have our extra loops, but let's see. Maybe we can fix this. So I'm going to save a copy of this. Because yeah, I want to keep that simple version. And then in here, oops, we'll add some extra edge loops to try to keep the algorithm from unnecessarily smoothing edges that we want to stay sharp. Okay, so let's see how that looks. Okay, we can see that did help a lot over here. Even with the smoothing on, it's still relatively sharp. Although these, with constant tessellation, the you can see this area is extremely dense in vertices, but that's just kind of a side effect of it. You could, I guess you could improve this by switching instead of a constant tessellation to world with depth. Although, okay, so this, I guess one issue here is that these faces are really long, so it still sees them as having a pretty big edge length. But I don't know, it could be worse. Okay, but that's kind of interesting. So okay, that's one way to do it. Another way is if we took this side, let's see, I guess we'll just leave this and I'll open back up the simple, and let's save this as colors. And then let's see if I can remember how to do edge painting. or sorry, vertex painting. So I want to select everything and set everything to black. Okay, well that's fine. Now nothing's going to be smooth though, so what I should do is go back and tell it to smooth these edges in the center. It's not going to look best around the top, but we'll just test this out. All right. Okay, so just to make sure this is working, I'm going to make a simple shader graph. It's an unlit to see if the vertex colors are being imported. Okay, so it's not gonna create empty X head colors. Okay, and then I'll create a new material here for the Vertex Colors testing. So shader graph, vertex color. Okay, so yeah, that is working right. Good to see. So now if I add tessellated lit test, okay, well nothing's gonna happen right now because I don't have vertex colors set up. So how do I want to deal with it? So basically what I need to do is be able to vary the smoothing, being able to vary the smoothing factor based on vertex colors. I don't really need to change anything in the comment, I don't think. So what I should do is just here, I guess in the shader, let's see. Let's see, toggle. Tessellation, smoothing, V colors. Okay, so multiply V color red in smoothing. Okay. I know that's really long, but I don't know what. I need to think of something better for that, but okay, so now I need. Okay, so this is going to have to go into almost every pass, any pass that has smoothing in it. So Pragma, shader, feature, local. Okay, so again, this Pragma just tells the compiler to make a version of this pass with the keyword enabled and then one with the keyword disabled. Anyway, we need it in all of the passes here, except for the meta pass, which I need to deal with that sometime. Okay, so if def tessellation smoothing vertex colors is defined, then we also need to get vertex. Oh, let's just do this colors. I guess it'd just be color. And then we'll need to pass it through here. I don't know if we can use that color semantic, but we'll soon find out. Okay, and then we can just pass through here. So output.color equals input.color. Okay, and then Okay, so we need to multiply, where is it? This tessellation smoothing value with the vertex color. So flipped smoothing equals oop, I guess I could just copy. And then if def, I don't remember the keyword now. Then smoothing times equals, okay, so we need to interpolate between the passes. So we'll do this barycentric interpolate. So it would be color.red. And then pass this value through here. Okay, so this using the lit test, but how come? Oh right, I need to make this mesh use smooth normals. Okay, so now it's got ugly smoothing, and then if I turn on this, there we go. I guess vertex colors are set to white by default, I guess, because all these other ones still have on all their smoothing, which is nice to see. Does the monkey actually? Let's turn on constant. So yeah, okay, so the monkey does have smoothing. But anyway, here you can see there's still a bit more sharp or smoothing than I thought would happen, because, well, I guess it's better than this, but maybe it's my actual model isn't really that good. I don't know. But yeah, it's not quite as sharp as I would expect. There's something. Okay, so this is kind of a bad artifact, but I think it's just because, yeah, this model isn't really made the best, but you can see the normal is sharp here, but then the sharpness creates like a kind of ugly shadow, even though it's not sharp at the top of the edge of the axe. Or what is going on there? I think it's just, yeah, the way that the Bezier curve works there. It's really extreme, I guess. Yeah, the quadratic normals look even worse, but anyway, so yeah, there's a couple ways that you can try to control the way the smoothing works on your model. I think this one looks better. I mean, right here you get a nice little highlight. But again, this model is also a lot more low poly, so it just kind of depends. Okay, let's see. So okay. I think we're just about done with tessellation, which is nice. I gotta do the meta pass, and then what else? I mean, I guess we gotta test it in other versions of Unity. And I'll probably do this off stream because it's not super exciting. Basically, you just find two vectors on the triangle pointing from points 1 to 2 and 2 to 3, or 1 to 2 and 1 to 3, and then take the cross product, and that'll give you the new normal vector. But I think I'll go ahead and wrap up for today. And tomorrow, I don't know, we might work on this. We might work on some better lighting in the shader graph. Like my patrons are voting on the next tutorial, which is what I would probably start researching, but I haven't finalized that yet. They have a couple more days. So we'll just see. But yeah, thanks everybody for coming by. I really do appreciate it. I hope this new time works for all of you. I think it's going to be best for me, so we'll see. And I hope I'll try to stick to it for a while. But yeah, if you enjoyed the stream and you'd like to check out my YouTube channel, or I have a bunch of game development tutorials, or just connect with me on any other social media, I'll put some links in the chat. And I'll be back tomorrow at about 2:15 US Eastern Time, and we'll continue with whatever game development we decide to do. But yeah, have a great night, and I'll see you later. Bye-bye.